So question 4, the function f is defined as follows: fx equal to root x minus 1 and x is greater than 1. Find an expression for f inverse x. So the domain of fx is range of f inverse x, right? This we would need while doing this. So first let's start. Let's fx equal to y. So y equal to root x minus 1, or root x equal to y plus 1, or x equal to y plus 1 whole squared, right? Therefore f inverse of x is x plus 1 whole square. So this is the interchanging that we do. So here, since there is no plus minus, it is automatically greater than 1, right? Okay. Part 2, the diagram shows the graph of y equal to gx, where gx equal to this for x e r. State the range of g and explain whether g inverse exists. Okay, state the range of g. So we will first use value of g, x equal to 0, and we'll see what the value of g is. Okay, so this is 0, so it should be half, no need calculator. Then we will use x equal to 1, where I'm telling you what I'm trying to do here. g1, that is 1 by 1 plus 2, which is 0.333. So now we'll also use x equal to minus 1. So we're using 0, so minus 1, 0 and 1. We're going to use all three. G minus 1 is equal to now, so 1 is equal to 1. Now see what is happening here. So we can see that whatever value we are using, whatever value of x we use, it will always be more than 0, right? Because it's whole square here. Even if you use minus 2, it will become 4 when you put the whole square, so it can never be less than 0. So that is what I was trying to test in these values first up. So the first thing is it would be greater than 0, gx. The second thing is we'll use a very, very, very large value. Let's say we use x equal to 10. So we will find let's use x equal to first, and let's say 4. So we find 0.0555. So it's a very small value. So here we have used x equal to 1. Let's try something like 2. So that is 0.17. Let's use x equal to let's say 1.5. That is 0.24. Let's use x equal to 0.1. So let's now use x equal to 0. So what I can see here, the max value of gx, you can trial and error different values, just like 1, 2, then go to 4s, 10s, then come down to 0.1s, 2s. This will take approximately 1 to 2 minutes, which you can definitely afford. It is important each mark is. So max value of gx is 0.5, which are found at x equal to 0. So the range, and it is 0.5, so less than equal to 5. So that is the range of gx. And now whether it has g inverse, we will have two tests. First, we will draw the y equal to x line like that. Sorry, that is like the worst y equal to x line maybe. So this is the y equal to x line. I cannot see any inverse, or we will use the straight line test, the horizontal line test, right? So we have two like intersection. So the explanation can be like this: it has no inverse. Sorry, there. So it has no inverse, as it is not a 1 1 function. Means one value of x can have more than one value of y, right? It's not a 1 1 function. I think I've just told you the opposite. No. So one value of y, like we can see, let's say this is 3, can have two values of x. So what this means is I'm so sorry, I told the opposite, of y can have many values of x. It has no inverse. Spelling of inverse is wrong as well, as it is not a 1 1 function. Or we can write it has no inverse, as it fails the horizontal line test. So in the horizontal line test, if there is one like intersection, then we can say that it has an inverse. But if there is more than one intersection, be that 2 3, that means it shows it is not a 1 1 function. That is, for one value of y, it has no only singular value of x, it has more than one value of x. So that is for that one. Part C. So the function h is defined by this equation. Solve the equation h f x equal to f 25 by 16. Give your answer in the form a plus b root c, where these are integers. So these are integers, very important. 4 marks we have. First, let's find out what is f 25 16, which is root of, what is that? Root of x 25 16 minus 1, which is 0.25. Now let's find out hfx. So inside function of h, this we have to put in fx. Fx is root x minus 1 whole square plus 2, which is 1 by x minus 2 root x plus 3. So that is hfx. So as per question, 1 by x minus 2 root x plus 3 is equivalent to 0.25, or x minus 2 root x plus 3 is equal to 1 by 0.25, which is also equal to 4. Or we have, if we could push the 2 root x to that section, that is x plus 3 minus 4 equal to 2 root x, and squaring both sides, square both sides, we get, first thing is this would become x minus 1 whole square, this would become x minus 1 whole square, right? So it would be x square minus 2x plus 1, and this would become 4, this would become x, so 4x, or x square minus 6x plus 1. I'm doing basic calculations. Or finally x is equal to, will we use the quadratic formula, so which is minus b plus minus root of b square minus 6 whole square minus 4 into a into c by 2 into 1, which is equal to, so 6 plus root of 36 minus 4 by 2. This gives me 3 plus 2 root 2. Since all of these are positive, so this has to be positive, this has to be positive, this has to be positive. So this will be your solution. Therefore a equal to 3, b equal to 2, c equal to 2. I hope that made quite a lot of sense. I'm trying to go a little slow. I hope it's not a problem. I'm trying to go very slow, so only at question 5 till now. So question 5, the first and second terms of an arithmetic progression are tan theta and sine theta respectively, where this is the range given. Given that theta equal to pi over 4, find the exact sum of the first 40 terms of the progression. So sorry guys, the video stopped. Okay, so d equal to sine theta minus tan theta, as these are the first and second terms, and it is an AP, which is sine pi by 4, since theta is given, minus tan pi by 4. Convert to radian mode and see what the value of this equation is. Sine pi divided 4 minus pi divided 4, which is minus 1 plus 0.5 root 2. So the first term is tan theta, which is tan theta equal to tan pi over 4, which is 1, and we need to find the sum of the first 40 terms. So therefore S40 is 40 by 2, n by 2, 2a, which is 2 into 1, plus the common first n minus 1, which is 40 minus 39, 1, which is 39, into the d, which is 0.5 root 2 minus 1, right? And this should be, they have asked to give the exact form, so let's simplify. So 2 plus 39 by 2 root 2 minus 39, 20 into 39 by 2 root 2, let's cancel the root 2 part, which is so multiplying this and this, we have 390, and multiplying this so plus 20 into 2 minus 39 is minus 37. So finally we should have 390 minus 20 into 37, which is, oh my god, but I've done a mistake. I completely omitted the root 2, so sorry. So we'll actually do one more thing. So let's simplify this more. So 20 39 by 2 root 2 minus 37, then 20, so this is 10 for this, then 390 root 2 minus 20 into 37, which is 390 root 2 minus 20 into 37 is 740. So that is the first part. The first and second terms of a geometric progression are tan theta and sine theta respectively, where 0, this is the range given. Find the sum to infinity of the progression in terms of theta. So the common ratio is the second term by the first term, which is sine theta by tan theta, which is sine theta divide tan theta, which is sine theta divide sine theta by cos theta, which is, because I just broke down this to sine theta by cos theta, which is equal to sine theta into cos theta by sine theta, which is cos theta. So the first term is tan theta, so S infinity is a by 1 minus r, which is tan theta by 1 minus cos theta. You could have tried to simplify this, but you don't need to. The mark scheme doesn't demand any more simplification, so that is 2 marks only, so I think that's the reason. Part B, given that theta equal to this, find the sum of the first 10 terms of the progression. So it's a geometric progression, giving your answer correct to 3 SFs. 3 SF is the answer. So the common ratio is cos pi by 3, as it was cos theta, cos pi divided by 3. So it's 0.5. Then the term 1 is tan theta, so tan pi by 3, which is root 3. Therefore, since the common ratio is, so we need to know the modulus of r is less than 1. So for that reason, I'm going to use our second formula. So s of 10 is root 3 1 minus 0.5 to the power 10 by 1 minus 0.5. So I'm using the second formula, and we should get the answer of 2 3 as of now. Root 3 1 minus 0.5 by 0.5, which is root 3 or 1 point, oh sorry, I did not put the power to the power 10. So there was a power 10, I missed it in the calculator, so ignore that. So which is equal to 3.46, right in the bracket 3SF. So that is question number 5. I think it was relatively easy compared to some other ones of those APGP questions they give.